Hello, I'm Carly. In this video, we will explore the detailed procedure for configuring an EB80 island in ETHERCAT using Omron's Sysmax Studio. I will guide you step by step through the process in a simple and clear manner. Stay with me to find out everything you need to know about this topic. On the left, in Configuration and Settings, double-click on ETHERCAT to display the network. Right-click on the master, display Library ESI. Install file. Select the ESI file corresponding to EB80. Return to the network. Now you need to add the device to the network. To make the search easier, at the top right of all manufacturers, I drop down the menu and select Metalwork Spa. Double-click on the device. Select the imported device on the right. You can change the identification name and assign the address to the node. Verify that the assigned node address matches the actual value. I go online with the PLC. Right-click on the master. Write the slave node address. If the two values do not match, change the set value entry. Proceed with writing. Restart the PLC to apply the change. Now I'm going offline. From Configuration and Settings, Map I/O, double-click. In the corresponding node, you can see the entire PDO mapping divided into individual bytes. The first 16 bytes are used to control the solenoid valve drivers. Each bit represents a single driver in ascending order, for a total of 128 drivers. By associating global variables of type byte create previously, we can interact with the physical addresses of EB80. Let's suppose we want to control the first 8 drivers. I associate a variable with the first byte of node 1. Now let's see how to change the SDO parameters of the drivers I want to control. Sysmax Studio does not have a section dedicated to modifying parameters. It is therefore necessary to write some programming code. In the global variables, create 2 SDO opening and closing objects. Create a section in the program. For convenience, it has already been created, and it is the pilot parameterization section. In the first branch, there is an inline ST block where the SDO opening and closing objects and other variables are initialized. These variables will be used later as inputs for the code function blocks. In the second branch, the SDO objects related to the 3 parameters to be sent to EB80 are initialized. These must be created beforehand and are of the same type as the opening and closing objects. Specifically, the first object enables parameter modification. The second object parameterizes the first 4 pilots. The third object parameterizes the remaining 4 drivers. For each SDO object with index and subindex, I uniquely identify the parameter. With the value entry, I assign it the desired value. Consult the EB80 Plus EtherCAT manual, which can be downloaded from the website for the complete parameter mapping and the values that can be assigned to them. As for the pilots, for each one it is possible to parameterize its behavior in the event of interrupted communication with the master, choosing between 3 options: hold last state, output reset, and output set. The actual code is now illustrated. Communication opening command. Opening function block. 3 function blocks for writing parameters. Communication closing function block that starts once writing is complete. Provide a program section that resets the EtherCAT network in the event of a communication error. Once this is done from the project menu, recompile the controller. I'm going online. From the controller menu, transfer to controller. I confirm. When the initial condition is met, the pilots will be parameterized. Great job. I hope you found this guide useful and clear. Thank you for watching this video with me.